Hi everyone, so welcome back to Nuskit. So let's solve today's daily LeetCode challenge, which is remove zero sum consecutive nodes from linked list. So let's try to read the problem statement first. So we are given the head of a linked list. We repeatedly delete consecutive sequences of nodes that sum to zero until there are no such sequences. After doing so, we need to return the head of the final linked list. You may return any such answer. So let's try to understand what the problem statements actually means. So here we are given a linked list which is 1, 2, minus 3, 3, 1. So now what we need to do is we need to basically remove some set of continuous values, or you can say nodes, where the sum is actually 0, right? Say for example, you can see that if I sum these numbers, or you can say if I sum these nodes, so the sum for these nodes will be actually 0, right? And we need to do this in entire linked list. Like wherever we are finding sum as 0, we need to remove those consecutive nodes and we need to return the left linked list, right? So the answer in this case would be 3, 1. There is one more way that we can remove these two nodes, minus 3 and 3, and then remaining nodes will be 1, 2 and 1, right? So any answer we can return actually. Similarly, in this case, if you just see this particular case, so here we need to remove these two nodes, 3 and minus 3. And thereafter we will left with 1, 2 and 4. So the answer would be 1, 2, 4. So I hope you have understood the problem statement clearly. Let's try to look at this, and we will be taking one example, and let's try to figure out how we can actually solve this particular problem. So here I have taken a very decent and simple example, right? 1, 2, minus 3, 4, 5, minus 2, 5 and minus 3. And I have assigned a unique address to each of the node. Let's say A, B, C, D, E, F, G, H, right? Let's try to figure out one thing which is very important, right? It's a very basic and simple concept in mathematics, right? Just think about it. Let's say for example, at any point in time, let's say you are at a value 0, let's say A. There is some value which is A, right? Now you add something to this value. So definitely if you are adding some positive number, it will go up, right? Now you are at this point. Now let's say you are reducing some value, right? Maybe something like that. You reduced, you added some negative number to it, so it will reduce the value, maybe, right? And then you do it multiple times. Like you are adding some number, then you are reducing it, then you are adding, then you are reducing, then maybe you are adding a bigger value, then you are adding a like you are adding a negative bigger value, and after some time you again come back to this A value, right? So what does it actually mean, right? So it will mean that sum of all these values will actually be 0, right? If you didn't understand that, let me take an example. Let's say for example, you are at initially 5, right? So this is, let's say, 5. Now you added some number to this, let's say plus 2. So this will go 7, right? Now let's try to subtract some number from it. So let's say I'm subtracting, let's say, minus 5, right? So this will bring the value to 2. Now let's say once again you add this number to 3, right? Like let's say you add plus 3. So now it will become again 5. Now if you actually look at these values, right, plus 2, minus 5 and plus 3. So what does it actually mean? 2, minus 5 and plus 3. What does it actually mean? It actually means that initially you had 5, right? Then you had to do plus 2, then you had to do minus 5, and then you had to do plus 3. So eventually what's happening is, at this point in time the sum was 5. Then you added 2, so some actually became 7. Then you added minus 5, so some actually became, let's say, 2, right? And then you actually once again added 3, and finally your sum once again is becoming 5. That means sum of all these values is 0, right? So this is something that we need to really look for in this particular example. That means we will kind of try to use prefix sum technique over here, right? Till every node we will try to maintain the prefix sum so far, and we will see whether we have already seen this particular prefix sum in our map, right? Okay, so say for example, let's say at any point in time you encountered, okay, the current sum is, let's say, 5. So you stored 5 in your hash map, right? Maybe the address of this particular 5 node, right? Address of 5. Then you moved next. So the current sum actually became 7. Then you moved next. So current sum actually became 2. And then you again moved next. So again your current sum became actually 5. Which means that now you are actually seeing this 5 once again, right? Because you have already seen it in past. And who is telling you? HashMap is telling you, right? So this is a kind of approach that we will be using in this particular example to solve it, right? So let's try to look at this and how we are gonna solve it. So initially what I will do, initially I will add one 0 to it, right? A dummy node. The reason for that is simple. Say for example, if linked list was something like this, let's say, not this, let's say the linked list was something like this, 1 and minus 1, right? So now what you will do, let's say the prefix sum so far is 1. Okay, maybe you added the, let's say address of this one is A and address of this -1 node is, let's say, B. Let's say for example, right now your current pointer is this. So you will see, okay, current sum is 1, 1 is not there in your hash map. So you will add it for the future, right? So let's say you added it. Now you move to the next. Now you will say, okay, 1, now the current sum will become actually 0, but is there 0 in your hash map? No. So you will kind of add it. But ideally what should have happened is, you should have already 0 in this particular map, because you would have removed it, right? If 0 was there, because these two nodes ideally should be removed, right? Because at this point in time sum is becoming 0, and initially you won't be having any sum, right? So ideally you should start with sum by default, assuming that, okay, your initial sum would be 0. What I'm trying to say is, it's simple that, okay, let's create a dummy node, right? Let's try to create a dummy node, and let's say this is D, not D, let's say dummy, right? And now what I will do, I will simply try to add this dummy node in my map. So let's say this is my map. So what I will do, I will say, okay, 0 sum and add the dummy address. So this is the dummy address, right? Great. Now let's move to the next. Now let's take a prefix sum. Let's take a prefix sum. Prefix sum. Okay, this is prefix sum variable in which I will be maintaining the prefix sum. And let's say this is my current pointer. So let's call it as PTR, right? PTR. This is my PTR pointer. Now initially my prefix sum is 0. Great. Now let's move next. So add this current value, which is now sum. We will check whether we have seen 1 in past. No, we haven't seen. So just add 1 to this and add the address also. Great. Now let's move this pointer to the next. So this pointer will move over here. Okay, let's add the current value, which will become now 3. Have we ever seen 3 in past? No. So let's add this sum 3, and where we are getting sum 3? At 2. Sorry, at B node, right? So we will add the address. Great. Now let's move to the next. So now we have -3. So now let's add this -3. So if we add this -3 to this 3, so the sum would actually become 0. Now just think about it. If sum is becoming 0, that means just check this value, the current prefix sum, whether it's there already in your hash map. Yes, it's already there. That means the sum for these values, is actually 0. The sum for these values is actually 0, right? So what we will do, just think, just try to understand it properly. Otherwise you will understand it in code, but just try to focus, right? So what I will do now, I need to get that address from where the sum is actually becoming 0. What I mean is, I will try to get the address of this particular node, because sum of these node is actually becoming 0, right? So wherever this prefix sum is becoming 0, I will get the address of that particular sum, right? That, okay, in past where I have seen this 0 sum, right? So I will try to look for my past. Okay, in my past where I have seen this 0 sum previously, right? So this address, this hash map will help me give that particular node where I seen this 0 as a sum in past. I hope you are understanding it, right? So once I get that node, let's say I'm calling it as previous, right? Let's say I'm calling this node as previous. Okay, great. So I will simply ask map, okay, map, just give me the address of that particular node where I have seen 0 in my past. Okay, so I will get that address, and now this, I will call this node as previous. Great. Now what I will do, just try to think about it. What I will do, I will create a new pointer now, right, which is a temp pointer. So this is my temp pointer. Okay, this is my temp pointer. Great. And now what I will do, I will take a new sum, a temporary sum, which will be initialized to 0. Great. Just try to keep listening to me. You will definitely understand. I am making sure this, right? Just keep looking at this, what I'm saying. So what I did is, as of now, I simply asked my hash map to give me the previous dummy node where I have seen sum as 0, right? I simply assigned that particular node to be previous, right? Now what I'm doing is, I'm kind of iterating a new linked list now by setting this temporary pointer to the next of this previous. And now the idea is to remove all those sums which I have seen, right? The idea is simple, that I need to remove all those sums which I have seen just because of these two nodes, right? Great. Now, so I will simply set my prefix sum to 0. So the current sum to 0 basically. And now once again, I will iterate on this. So now let's add this particular node 1. So now sum is 1. Now let's go to the map and remove this particular 1 value. Why I'm doing so, I will tell you, don't worry. Just as of now, just keep looking. Great. Now let's move this temporary to the next pointer. So now my temporary now will become this. Great. And now once again, add this 2 to this sum, which will become now 3. Once again, remove this 3 from your hash map, and that's it, right? So you don't have to move to the next value, like you will okay, let's move once again, and now you will point to this. So until you don't point to this particular pointer, you will keep running your loop. But as of now, because your temporary pointer is actually pointing to the pointer, now you will stop this particular iteration. So this was your temporary work, right? This was your temporary work. Okay, great. Now let's remove this, and now what we will do, we will simply say, once you do this, once you remove all those values which were there in HashMap just because of these values, once you complete this part, what you will do, you will say previous.next to pointer.next, previous.next to pointer.next. That means you are kind of removing all these nodes. I hope you are getting this point, right? So I have removed all these nodes, and eventually what would happen is that this 0 will be pointing to this node, right? I hope you understood this. Great. So let me just remove it now because it is pointing to this. Great. And your pointer will also move to the next value now. Great. Nice. Now we will again start. So now the current sum is 4. Have we ever seen 4? No. Don't worry, I will tell you that part, like why we removed the sum which was created from these values, right? I will tell you, don't worry. Great. Now let's look at this. So current sum is 4. We haven't seen 4, so just add 4 at address D. Great. Now let's move to the next node. So pointer now become this 5. Let's add this, so the sum will become 9. We haven't seen this 9 in past, so just add some 9 to this address, which is E. Great. And now let's move your pointer to the next. So pointer will become this. Great. Now let's add this -2, so it will become 7. Have we ever seen 7? No. So just add this 7 at address F. Great. Nice. Let's move next. So now this pointer will become 5. So let's add 7 and 5, 12. Great. And we haven't really seen this 12, so let's add this to this G address. Great. And then let's move this pointer to the next, which is -3. So if I remove this -3, so it will become 9. Now it's very important. Have we ever seen 9? Just think of it, right? Have we ever seen 9? Yes, we have seen 9, right? Where we have seen 9? At address E. At address E we have seen 9, right? That means what I will do, I will now create a new previous variable which will point to this particular address, which is E, because at E I actually saw 9, right? Because just think about it, right? See, I need to point to that node after which the sum is becoming 0, right? So previously I saw 9 at this point in time. Previously I saw 9 at this particular node. After this, again I am landing at 9 sum only. That means for these particular nodes, the sum is becoming 0, right? That's the idea of this particular approach, right? Great. Now, once I found this, I need to make sure that I remove whatever sum is being created because of these nodes, right? So what I'll do, I'll simply say, okay, now start a new pointer, which is temp, which will be pointing to the next of the previous, and I will initialize my sum to my current prefix sum, which is 9, right? So kind of I'm basically going in past, creating sum from this particular node, and now whatever new sum will be formed, I will try to remove this sum. And still, I'm telling you once again, reason I haven't told you, right? I will tell you the reason right after this example, right? So let's do that, right? So now temp is -2, so this will become 7. So let's remove this 7 node from the hash map. Great. Now let's move this temp pointer to the next. So now temp will become this. Great. Now this 7 and 5 will become 12. So now 12. Let's remove 12 from my hash map. Great. And now let's move this temp to the next. And once again, like temp is because temp is pointing to pointer, so we will not sum this, right? We will not remove anything from now, right? And finally, once we iterate this, what we will do, we will simply say, okay, just point. So what I will do, I'll simply say previous.next will become actually current pointer to the next, which is null, which means I am kind of removing these values, from here, right? Great. I hope you have understood this part, right? And eventually you can see when your pointer will now move to the next value, so this will be pointing to null. Hence you have iterated the entire linked list, and your final linked list will be, because this was dummy node, right? So you will have to return dummy.next, which means you will be returning 4 and 5. Now let's try to understand why we are actually removing these particular nodes, right? So let me just give you an example for that. Let's say you have original linked list as 1, 2, and then -3, right? And then maybe 1 once again. Just look at this, right? And let's say we have now null, and then let's say we have, okay, so this is the original linked list, right? This is the head of the linked list. Now, as per the approach, what I have told you, we will create a new dummy node, right? Let's call it as dummy, okay? And for the simplicity, let me just give the names A, B, C, D, and E. Great. Now, I will start with this, okay, because I have created the dummy node, so my hash map would by default contain this 0 at dummy address, right? Great. Now let's start a new prefix sum. Okay, let's start a new prefix sum which is initially 0. So I will add the current value which is 1. Great. I have seen 1, no. So let's add this at address at address B. Great. Now let's move to the next value which is now become 3. So I ever seen 3? No. So let's add this 3 at address C. Great. Now move to the next, minus 3. So the sum will be now become 0, and I have already seen this prefix sum 0 at dummy node. So what I will do, I will point my previous to this particular node. I will initialize a temporary pointer. Now think about it. If I don't remove these node, let's say for example, without actually removing these particular sums from this hash map, if I directly point this previous dot next to this, let's say, if I directly do that, and I remove this, so kind of these values are actually removed now, right? These values are removed now, because without actually removing them, I have simply pointed just, okay, get the previous sum where the prefix sum was 0, and I will simply make sure that, okay, previous dot next is equals to pointer dot next, right? And now your pointer is actually this. And now let's try to add once again the sum. So what is the current pointer value, which is 1? So this is 1 now. Now just think about it. 1 is already there in hash map. If I don't remove these values, which was added because of these nodes, which I have already removed, if I don't remove these sums from my hash map, so this problem will be actually happening, right? Now you just see, initially we were having 1, 2 and minus 3. We already removed them because some of these values were 0. So we already removed them. But now once again we are getting 1, and 1 is already there in my hash map because I didn't remove it. And this one was added because of this particular one, right? So because I am getting 1, I'm able to see this 1 already in my hash map, which means that once again you are forming sum 0, which is wrong. We are not really forming sum 0, right? So this is why what we will do, we will try to remove all those nodes from between, like we will try to remove all those sums which we stored in my hash map, which was created from those nodes which were part of my continuous sequence, which was forming 0, right? Let me repeat it once again. We will try to remove all those sums which are there in my hash map, which were added just because of the fact that whatever nodes were there in my linked list, they were consecutive and they were forming a sequence of zeros, like they were forming a sequence of sum of zeros, right? So I will try to remove all those sums which were added because of these nodes. Otherwise, I will kind of will fall into this kind of trap, right? I hope you understood this problem, right? So now let's try to code this problem because this is very easy. So what I'll do, I'll simply say, okay, let's create a map of integer, comma, list node, right? And this would be a prefix sum map. Let's call it as prefix sum map, new hash map, right? Great. And now we will create a list node dummy node is equals to new list node, which is 0, right? And I will simply point dummy dot next to my head. Great. And I will say, okay, prefix sum map, I will put this 0 with dummy address, right? Great. And now I will take a list node pointer, which will help me to keep track of my linked list, and this will be pointing to head initially. And I will take a variable also, which is prefix sum, which will be initially 0. And now we will run this loop until my pointer is not equals to null. I will try to run this loop, and what I will do, I will simply say, okay, first of all, add the current value. So prefix sum will be equals to ptr.val, right? And now I will check whatever prefix sum I have got, whether this prefix sum is already there in my hash map. So I will simply say whether my hash map contains this particular key which is generated from prefix sum. I am simply saying, okay, whether I have seen this prefix sum previously. So if that is the case, so let's create a node, previous node, right? Let's call it as previous, which will be my prefix sum map dot get prefix sum, right? So I am simply pointing that previous node, and now I am taking a new node also, which is a temporary node, which will be pointing to previous dot next, right? This will be previous dot next. Great. And I will take a current sum, which is a temporary sum, which will be pointing to prefix sum. So now I am taking this sum just to remove all those new values, right? All those new values. So what I'll do, I'll say until my temp is not equals to pointer, right? Until my temp is not equals to pointer, I will add the current sum, which is temp.val, right? Temp.val, and I will ask my prefix sum map to remove that particular value, right? So I will simply say, let's remove this particular sum from there. And now make temp is equals to temp.next. temp.next. Great. And once this is done, what I will do, I will say, because after removing all those sums which are there in my hash map, because of those nodes which are actually making sum 0, right? Once I do that, what I will do now, I will make a connection. So previous.next will become previous pointer.next, right? So kind of I'm like pointing that 0 to the next value, like after removing the nodes from between, right? And if that is not the case, like if I haven't seen this prefix sum, right? Because there will be two cases: either I have seen the prefix sum, in my map or not, right? So if I haven't seen this current sum in my map, so what I will do, I will simply say that add this particular current prefix sum with the current address, which is ptr, right? That's it. And at last, every time, like in this while loop, every time what I'll do, I'll simply say ptr is equals to ptr.next, right? And this is it. Now we will do, once this loop is ended, we will return actually dummy.next, return dummy.next, right? So now let's try to run this. This problem is actually, you will be able to understand it more if you will try to do it by yourself. Okay, we have ignored this semicolon. We cannot forget semicolon. So now let's try to run this. It is accepted. Let's try to submit it, and finally it will be submitted, right? So if I talk about the time and space complexity, it's big of n and big of n, right? Because it is possible that all the possible values in the map, in the linked list are positive, right? All the values are positive in the linked list. So now if I will try to calculate the prefix sum, it will always be a positive and it will be a different value always, right? So we might end up storing n number of different sums in my hash map, right? So this can lead to big of n space, and we are kind of iterating every node twice, one with this pointer and again with this pointer, temp pointer, right? So big of n is the time. So I hope you have understood this problem, and I will see you in the next video. Till then, bye bye.